Question 17, we've got a proofs question. We're told that p and q are positive integers with q greater than p. And we've got a statement here that q cubed minus p cubed is never a multiple of 5. Show by means of a counterexample that statement 1 is not true. I hate these because you could spend a lot of time trying to prove this and getting nowhere. But let's have a go. Now, because these are positive integers, I can't use the usual trick of making one of these guys negative. So let's just try numbers which are multiples of 5, because that's the best chance that the difference will be a multiple of 5. So for part A, I'm going to say the smaller number p, let's say p is equal to 5, and q, well, the next multiple up from 5 is 10. So therefore q cubed minus p cubed must be equal to, this is 1,000, minus 5 times 5 times 5 is 125, which is equal to 875, which is a multiple of 5. So the statement is not true. So let's go on to part B. P and Q are now consecutive even numbers. And we're supposed to prove that q cubed minus p cubed is a multiple of 8. So 8 will pop out as a factor after we've performed all the algebra necessary. Consecutive even numbers. Well, an even number is 2n, and the next number up is 2n plus 2. They would be consecutive even numbers. So this is p and this is q, given that q must be greater than p. So q cubed minus p cubed is equal to 2n plus 2 cubed minus 2n cubed. Multiplying this out, I'm going to leave one of the brackets here and then multiply the remaining 2 brackets out and form a quadratic. So this will be 4n squared plus 8n plus 4, and this is minus, I might as well multiply this out, this is 8n cubed. So multiplying all terms first by 2n, I get 8n cubed plus 16n squared plus 8n. And now all terms multiplied by the 2, I get 8n squared plus 16n plus 8. And we've got to remember our minus 8n cubed. Those 2 terms cancel. So gathering up the n squareds, we get 24n squared. So those 2. Now the n's, 8 and 16, we've got another 24n plus the remaining 8. So this is equal to, I can take an 8 out of the whole thing, and this is 3n squared plus 3n plus 1. And therefore, statement is true, as 8 is a factor. And there's the answer.